Welcome to Lesson 10, IPv6, the address format that looks scary but really isn't. Here's the short version of why it exists. IPv4 gives us about 4.3 billion addresses, but the world has 5.5 billion internet users, plus tens of billions of smart devices. The math broke years ago. IPv6 is the long-term fix, 128 bits per address, enough for every grain of sand on Earth, with billions to spare. And by the end of this lesson, you'll read addresses like 2001.8.1 without flinching. So let's rewind and see how we got here. When IPv4 was designed back in 1981, 4.3 billion addresses felt limitless. There were maybe 50,000 hosts on the entire internet, and computers still filled rooms. Then the web showed up, then smartphones, then the Internet of Things. And on February 3rd, 2011, IANA handed out its last block. We bought ourselves another decade with NAT, sharing one public IP across a whole household. But that was a band-aid. IPv6, with its 128 bits and roughly 340 undecillion addresses, is the actual fix. So what does one of these 340 undecillion addresses actually look like? 8 groups of 4 hex digits separated by colons, 128 bits total, written in hex because 32 characters beats 128 ones and zeros. The good news? You almost never write the full thing. Leading zeros inside a group can drop, and a run of all 0 groups collapses to a double colon, used once per address, so it stays unambiguous. That's why the loopback, the IPv6 version of 127.0.01, is just 2 characters, : 1. Now let's actually feel the size difference. IPv4 gives us 32 bits, about 4.3 billion addresses, which sounds like a lot until you remember we ran out in 2011. IPv6 gives us 128 bits, 3.4 times 10 to the 38th. If IPv4 is a baseball, IPv6 is the visible universe, every grain of sand on Earth, multiplied by every star in the sky. That's the gap. But size is only part of the story. IPv6 also fixed things IPv offshore had been duct taping for decades. No more NAT. Every device gets a real public address. Auto configuration is built in, so devices can assign themselves an address without a DHCP server. Encryption lives inside the protocol instead of being bolted on. The header is a clean fixed 40 bytes, and broadcast is gone, replaced by smarter multicast. TCP and UDP, though, those still work exactly the same. So if IPv6 is so much better, why hasn't it taken over? Because the internet is enormous and you can't reboot billions of devices on a Tuesday. The reality in 2026 is dual stack. Your laptop quietly runs both v4 and v6 at the same time. Open a terminal, type ipconfig or ifconfig, and you'll see them sitting there together. The OS prefers v6 when it can, falls back to v4 when it can't. Globally, about 40% of traffic to Google already rides on IPv6, over 80% in India, 55% in the US, but legacy hardware and corporate apps will keep v4 alive for another 20 years easy. For Help Desk, the takeaways are simple. Don't be surprised when both show up. Remember that. One is just the v6 version of 127.0.0, and if an app misbehaves, try disabling v6 for that one app, never the whole system. Time to put faces to names. 5 real IPv6 addresses you'll actually meet. : 1 is loopback. Same idea as 127.0.01, just shorter. Anything starting with FE80 is link local, auto-assigned, only valid on that one network segment. The 2001 DB8 prefix is reserved for documentation, so if you see it in a tutorial, it's never a live address. And those last 2, memorize them. 26.6, 3700, 4700, 11.1 is Cloudflare. 2001. Assure is Google. The IPv6 twins of 1.1.1.1 and 8.8.8.8. Now let's lock in the vocabulary. These 12 terms show up in every IPv6 document, ticket, and config you'll ever touch. You already know some. IPv6 itself, hex, the double colon, loopback, link local, global unicast. Add a few new ones, multicast for sending to a group, prefix for the network portion, slide for auto configuration without DHCP, dual stack for running v4 and v6 side by side, IPsec for built-in encryption, and NAT64 for translating between the two worlds. Memorize these 12, and the next 7 lessons will feel like review. Before we wrap up, let's clear out 5 myths that cause real damage on real tickets. First, IPv6 does not replace IPv4 yet. Disable v4 globally, and half your apps break. Second, IPv6 isn't automatically more secure. Misconfigured firewalls often leave v6 wide open while v4 is locked down. Third, your ISP probably does support it, just not by default. Fourth, it's not slower, simpler headers, no NAT, often microseconds faster. And fifth, NAT64 is a bridge, not a permanent fixture. Believe these and you'll skip the classic "I disabled IPv6 and now nothing works" story. And that's IPv6 locked in. 128 bits, written in hex with the double colon shortcut collapsing those 0 runs, and dual stack, quietly running both protocols side by side until the world finishes catching up. Next lesson, we drop down a layer to the hardware itself. MAC addresses, the 6-byte ID burned into every network card, and why it works hand in hand with IP. 7 networking lessons left in Stage 2. See you in Lesson 11.